Hi everyone, let's start solving today's LeetCode daily challenge question, which is 101 symmetric tree. This question is marked as easy. I will tell you why this question is marked as easy. Let's try to understand the question first. Given the root of a binary tree, check whether it is a mirror of itself or not. Okay, so if I try to understand this question, so we need to check the left subtree and the right subtree is a mirror of itself or not. Okay. So I am saying that left is equal to right. Here, if I try to mirror itself, okay, 3 and 4, if I place in the front of a mirror, so it will be seen to me 4, 3 as nodes. Okay, so this is also correct. Yeah, so this if this thing is visible to me, I can say that yeah, this tree is symmetric tree. So what we need to check in this question is a symmetricity between the subtrees of the root. Okay, so let me come to that why this question is marked as easy, because how we are checking as our eyes, we need to implement the same thing into our question as code. Same thing. There is no other approach we need to apply if we want. We can directly solve this question as we are seeing this question. How we are solving this question that I am checking node with this node, checking this node with this node, checking this node with this node. The same thing I am doing with my particular eyes. We need to write the same thing in the code as well. That's why this question is marked as easy, because we are applying the naive approach in this question. Okay, the thing we are seeing, the same thing we are implementing here. Okay, so if I try to understand a example here, okay, let me take the above example only. So do I need to compare root with anything? No. Okay, so this will come under my base case. Okay, okay, because if this is null, I can simply return a null or a false or a true. No, if this is null, I can simply return a true, because there is nothing I need to compare it with. Okay, so root, I do not have to take care of anything. The main thing come, I need to check for the subtrees. So if I came to left subtree and the right subtree, can I take this left subtree and right subtree as a subproblem? I am saying what I mean by that. Can I take 2, 3 and 4 as a subproblem which I need to compare with 2, 4 and 3? Okay. Now in this case, I need to compare this root node with this root node. Let's say let this is A and this is B. I need to compare A with B. Okay, if A is equal to B, I need to come to this in the left part. Here, if I coming in the left direction, in this problem, I need to come in the right direction. Okay, here. So I will see this again. After completing this left sub problem, I will come to the right sub problem. If I am coming to right sub problem, in this B subtree, I need to check with the left sub problem. Okay, so here in this case, as you can see, I am using the DFS, like the depth first search. So what is that? What I mean by that, I am completing first my left sub problem, all of the left sub problems, then I am coming back to my right sub problem. And what are the traversal I am using in this case? As you seen, I process first the node, then the left, then the right subtree. First I process the node, then I process the left, then I process the right subproblem, right subtree. So this is nothing but known as pre-order traversal. So we are sure which traversal technique I need to use here, which is pre-order, where I process the node first, then the left subtree, then the right subtree. Okay, pre-order traversal is my traversal that I finalized. Okay, I can see like I can treat a subtree as a subproblem. Okay, so recursion is possible. Okay, if these things are confirmed, can I check? One more example. So let me take this example. Root I did not have to compare with anything. Now I need to take this example. This belongs to null. Now this is giving me 3. Let me take this as A. Let me take this as B. Okay. 2. This is giving me null. And this here is 3. If these are symmetrical, shouldn't the answer be look like 2 null? Shouldn't the answer should be 2 null 3? If it is symmetric with this, it will be look like something 2 3 and null. Okay, but this is not right. So how I will check that? Okay, as we checked that the sub problem is here. Okay, okay, I will check the root value first. Is the root value of A is equal to root value of B? Yes. Then I will go to left. If I'm going in this problem left, I need to go in this right direction in B sub problem. Okay, in B tree, I will go in the right subtree. If I'm going in the A of left subtree, I can do the vice versa. If I'm going in the right direction, I need to go in the left direction of B subtree to check the symmetricity, that the symmetric tree is mirror image of itself or not. Okay, so I went in left and here I went in right direction. I am saying A is equal to null, but B is not equal to null. The value I can compare later if both are the elements are not null. If A is null and I will try to check the value it with B, it will give me a null pointer exception. Okay, so first this is my base case. I can say that what is my base case. So let me discuss all the base cases with you as well. Okay, so what are the base case? Base case 1, if A is also null and B is also null, so I will return true here. Base case 2, if A is null, so if I check this property and if I say if A is equal to null or B is equal to null, I will send false here because one of the things is null. Okay, because with the help of first case I checked that if one of the property is null, with the base case 2 I am checking that one of the root is null. Okay, in this case either A is null or either B is null, so that tree is not same. Okay, and what will be the base case 3? Base case 3 will be if A dot val is not equal to B dot val. In this case I will return false. Okay, so these are all my base cases. Let me give you a pseudo code of this. What is the pseudo code of this? Why I'm writing the pseudo code for this question? Because this is a very easy question. Okay, so let me give you a boolean. Okay, I will return a boolean is symmetric, where I will get a tree node. Let name it is I have given the root. Okay, so I will check the base case. What is my base case? If root is equal to null, I will simply return true in this case because I don't have anything to check it with. Okay, now I need to I will return a check function where I will send root dot left and root dot right. Okay, so let me write the check function. What is the check function is saying? Okay, public, this is a pseudo code only. This will return a boolean. The name of this function is check. what will it will I am accepting as a parameters node tree node A, tree node B. So I will write out the first base case. What is the first base case? If A is equal to null and B is equal to null. In this case, I need to return true. Okay. If A is equal to null or B is equal to null. So from the first base case, I have concluded that both the A and B are null. But if one of the value is null, I need to return false. Okay. There is a third base case as well. So this is base case 1, base case 2. There is base case 3 as well. What is base case 3? If A dot value is not equal to B dot value. So this in this case, this is base case 3. I need to return false here. Okay. As you can see here, I am checking step by step. First, I checked both the A and B are null. Then I check the base case. If one of the elements are null, then I check one of the root value is not equal to another root value. So if all the three conditions are not satisfied, it means I can go to the next sub problem, which is I can return. I will do a recursive call of check where I will send. If I am going to A dot left, I need to send B dot right. And do I need to end here? No, I need to check right as well. Okay, so I will do a end operation with check of A dot right. And if I'm going in the right direction of the A subprogram, then I need to go into the B of left. Okay, so so that's it. My check function is completed. And if I talk about the time complexity, let me go in the time complexity part as well. So time complexity is nothing. I am iterating the whole tree once only, and I am accessing the whole elements one time only. So that will give me order of n. Okay, and if I give you the space complexity, so how much is the space complexity? It is nothing but the height of the tree. Okay, because after the height is completed, I am returning to the parent node. So it is nothing. If I say the height of the tree is h, so that is the space complexity of the recursive core stack. This is not an explicit data structure I am using to store something, but this is the recursive stack call, stack space. Okay, so that's it from my side. It is an easy question. I hope you like. I hope this video helped you, and if this video helped you, please like this video and subscribe to the channel. Okay, thank you. Bye.